So welcome to grade 8 math. We are looking at lesson 1.1, which is on prime and composite numbers. And so let's look at the definition of the two of them, and let's take these down in our notes. So a prime number, so you may have seen this term before. Prime number really refers to a certain set of numbers where it only has two factors, which means that that number can only be divided by itself and 1. So there are no other factors except itself and 1. So the definition is a prime number is a number that has only, that's a very important word in the definition, two factors. The number itself and 1, which means no other number can divide evenly into that original number. So for example, the number 17 is prime because the only numbers that I can divide 17 by and that give me a whole number answer are 1, because 17 divided by 1 is 17, and 17 divided by 17 is 1. As you can see, if you remember from grade 7, the factor rainbow, that 1 and 17 are pairs because 1 times 17 is 17, or 17 times 1 is 17. So it's its own pair. And there are no other numbers that can divide evenly into 17. So 17 divided by 2 does not give a whole number, 17 divided by 3, etc., and etc. A composite number is basically the opposite of a prime number, and this is a number that has 3 or more factors. So the two factors that are always going to be in the number is the number 1, because 1 goes into every number, and the number itself. So for example, the number 6, for example, the number 6 can be divided by 1. 6 divided by 1 is 6. Also, 6 divided by itself. So 1 and 6 are partners. However, other numbers can also go into 6. So 6 divided by 2 gives 3, and 6 divided by 3 is 2. So they're partners as well. So let's look at a couple of examples, and we'll take these down in our notebooks. Example 1, explain why even numbers, apart from the number 2, cannot be prime. Explain why numbers greater than 3 that are divisible by 3 are not prime either. Well, if we look at problem solving, the first step is see what we need. And as we can see here, these are two separate questions. So we'll start with question 1, explain why even numbers cannot be prime. Well, the way we can solve this problem is by looking at the definition of what's an even number. An even number is any number that ends in 0, 2, 4, 6, or 8. I think we remember that from an earlier grade. What makes those special, though, is that they can be evenly divided. They're called even numbers because they can be separated into two different groups, which means that all even numbers are divisible by 2. Which means you can always share it in two groups. If you took the number and divide them into two groups, how many would be in each group? So why can't they be prime? Well, if you look at the definition of the word prime, prime means it only has two factors, itself and 1. But now that we have another factor in there, we know that 2 is a factor. So which means 2 must be a factor. So it can't be prime because any number that is even will have 3 factors at least. It'll have 1 as a factor, it'll have the original number as a factor, and it will have the number 2 as a factor because it's even, because that number can be divided by 2. So the reason is why it can't be prime is even numbers must have at least 3 factors. 1 itself and the number 2, which makes it then composite. making the number composite. Okay, let's look at the second half of the question. Explain why numbers greater than 3 that are divisible by 3 are not prime either. Well, this is actually kind of related to the first question, because even numbers are divisible by 2. So which means that numbers that are divisible by 3 means that numbers divisible by 3 have 3 as a factor. So numbers divisible by 3 have 3 as a factor. Meaning that that original number must have at least 3 factors again. It must have the number 1 itself, the number 3 as a factor because it's divisible by 3, and actually its partner. So whatever 3's partner is in the factor rainbow, that's also a factor. So which means it can't be prime again. So it has at least 3 factors, possibly even 4 factors. Now, how do we know if a number is prime? To find out if a number is prime, divide all the prime numbers smaller than its square root to see if it's divisible. Which basically means it's easy to say, try out all the numbers below its square root. Or try out all the numbers until you start repeating numbers by itself. So, let's see if 187 is a prime number. So we take 187. Well, we know definitely its partners are 1 and itself, because 187 divided by 1 is 187. 187 divided by 187 is 1. So these are at least our 2 factors. Well, we have to see if there's other factors as well. Well, let's start the number 2. And we know that it's not an even number because it ends in a 7, so it has to be odd. So now let's pull up a calculator and let's look. Let's slide this in here. And we'll just try this out. 187 divided by 2. Well, we know because it ends in a 7 that it's not even. So we'll have to try other. We know that that won't give a whole number. So that's not a factor. 187 divided by 3. If you remember our divisibility rules from from grade 7, we add up all the numbers to see if it's a multiple of 3, to see if the original number is a multiple of 3. So 1 plus 8 is 9, and 9 plus 7 is 16. So 16 is not a multiple of 3, so which means that 187 is not a multiple of 3. So we can use our calculator to confirm that, and we'd see it's not a whole number as well. Now, 187 divided by 4. Now, the reason why we're not going to try 4 is because we look at other numbers that we've tried, and we know that 4 is an even number, so if it's an even number, that means 2 must be a factor of it. But because 2 never worked, then 4 will definitely not work. So this is why we're going to be using only prime numbers, because composite numbers, we would have already tried numbers below it. 187 divided by the next prime number is 5. And if you remember divisibility rules, numbers that end in 0 and 5 are multiples of 5. 187 does not end in a 0 or 5, so this is not going to work as well. Should we try 6? Well, I hope you said no, because 6 is even. And because 6 is even, that means we know that if 2 doesn't work, then 6 definitely doesn't work, because 2 also goes into 6. And so if it can go into the smaller number, it won't go into the larger number. The next number that we're going to try that's prime is 7. Now, there are no divisibility rules for 7 that are quite easy. So in this case, we can use a calculator, or we can long divide. For purposes of time, I'm just going to long divide, use the calculator. And I see that it doesn't work in that case again. So we don't get a whole number. We won't try 8 because we know that 8 is an even number. If we try 9, 9 is not a prime number, but we tried 3. So, and because 3 is a factor of 9, we don't need to try 9 because we know 9 won't work either. 10 we won't use because it's not prime, so we'll try 11. 187 divided by 11. Oh, And we see that the answer is 17. Now, what does that tell us? That means that 11 can go into 187 17 times. Or, if we say 187 divided by 11 groups, there'd be 17 people in each group. So now we know that 11 is a factor. If 11 is a factor, its partner must also be a factor. So 11 and 17 are both factors of 187. Because I have this, 187 is not prime because it has 3 or more factors, or in this case I could have just had 4 factors, but it has 3 or more factors because that's the definition of a composite number, making 187 a composite number. So a couple of things to just recap. Prime numbers only have 2 factors, itself and 1. A composite number is a number that has 3 or more factors. Now the number 1 is a very special number. It doesn't actually fall under any of the categories. Some websites call it a prime number, some websites don't call it anything, they just call it the number 1. It doesn't fall into under any category. So unfortunately, I won't be asking you what the number 1 is on the test because it doesn't really fall into any other category. It's not prime, nor is it composite. But some places, some websites can argue that it's prime, so that could be a debate that we can take up in class to see whether you think that the number 1 should be considered a prime number. So we'll take a look at these questions in class, and we'll do some problem solving, and if you have any questions, we can get back to that tomorrow. Great. Hope you understood it.